We're going to do, this is a definition page, the terminology. We're going to come back to that. Once we learn something, we put the definition in. Okay? So this will be where we come back to. We're going to go to this page here. Fundamental accounting principle. Okay? So the terminology page we're going to flip over because we're going to come back to terminology, fill it in as we go along. So here it says, solve problems involving the fundamental accounting principle. Also, note to self, don't cut down names throughout this notes booklet. It is family members of mine, mostly my children or my nieces and nephews. If you're like, well, that's a stupid name, just keep it inside. Keep it in, yeah? Keep it in your interior, right? London is my daughter. Don't start with her. Okay, she's lovely. You would all love her. She's just the nicest little human being. She'd come up and she'd be like, you know what, you're awesome. Like, that's literally how she is. She's great. Okay? All right, example 1. So we have London is shopping for a sports utility vehicle. If you didn't know that that's what SUV stands for. It is. Sports utility vehicle. Oh, some people learn it. All right. So the dealer says that he has 3 different models, Bronco, Explorer, and Expedition, and that each model is available in 5 different colors, gray, brown, white, black, and blue. So here it says, complete a tree diagram to determine how many different choices London has. Now, it is called a tree diagram, but it's more so like an anti-gravity shrub, okay? It's going to go this way. It's not like a tree. It's like if you took a tree, put it on its side, and then tree. Okay? Now, what I'm going to say to you as well is that you're not going to listen to me. I'm going to say, make sure you do this. Then we're going to practice question on our own, and you guys are all going to go like this, like a tree. Prove me wrong, please. It doesn't look like an actual tree. If it does, you know you're wrong. Okay? So, you also need to leave enough space. So here, the model we have is Bronco, Explorer, and Expedition, correct? Off of each model, we're going to get branches. How many branches are we going to get? 5. So if we write them like this, this, and this, right on top of each other, do we have enough for 5 branches coming off of those things? No. So when I make space, you should make spaces too. So along the top, we put the title. So model. Okay, cool. Then we're going to have Bronco. I'm going to leave. I need a pen. That would help. So I'm going to have Bronco. Explorer. And Expedition. So you see how I'm writing them down, one on top of the other, correct? Then I'll get you guys to do the question, and you guys are going to write them along the top and do branches like this down. I'm like, okay? So you write one on top of the next, on top of the next, and branches are coming out like this, like an alligator, one might say. I've never said that, but my hand started doing it, so that's what I'm going with. Alligator. Because you guys do this, and that's just weird. It's like a seal, but that doesn't know what to do with its hands. Can we just alligator, please? Okay. So, Bronco. We have gray, brown, white, black, blue. Gray, brown, white, black, blue. Gray, brown, white, black, blue. So we have gray, brown, white, black, blue. Bless you. Mackenzie, can you just Give that door a little shovey shove, please. Thank you. Okay, so we have all of our options shown in front of us, right? We can have a Bronco in gray, a Bronco in brown, a Bronco in white, Bronco in black, Bronco in blue, Explorer in gray, Explorer in brown, Explorer in white, Explorer in black, Explorer in blue, Expedition gray, brown, white, black, blue, right? So how many different outcomes is that? 15, right? 15 different outcomes. So outcomes, there are 15 different. And we could list them all, but I'm being lazy and it's a Friday. So normally under this outcome, we would list all of the different outcomes. Bronco gray, Bronco brown, Bronco white. Down here it gives, London has what? How many choices?
15.
London, 15 choices. That's good English, London. London has 15 choices. What did you do to get that answer? Yeah.
3 times 5.
3 times 5. You took the number of outcomes on the one times the number of outcomes on the other, because we could only choose one model and one color. If you could choose like one model and 2 different colors, then you wouldn't be able to do 3 times 5. You'd have to do it in a different way. But if we're only choosing one of each item, we can just multiply, which is the fundamental counting principle. So let's look at this one. Look at the number of choices there are for the model and the number of choices there are for the color. How do you use these numbers? Owen said, well, we could go model and say there's 5 of them. That's a lie. There are 3 of them. And color, there are 5. So that equals 15. We can only, this is the fundamental counting principle, essentially. We can only do it if we're picking one of each type, though. If we pick 2 of each type, we cannot. Yeah? All right. So, the dealer tells London that each of the SUVs come in 2 editions, SE and LE, standard edition and leather edition. How many different choices does she have then? So we would have our model still. How many were there? There was 3. We'd still have the and, so we multiply. We still have the 5 colors. But now what are we adding? And additions, right? How many were there? 2. So if I took each of those 15 vehicles and I said, okay, you can have a standard edition for all 15 or a leather edition for all 15, how many would we have now? 30. So London has 30 different choices. We're going to flip over. Okay, what we just did was called the fundamental counting principle. I am struggling today with speaking. Can be extended to more than 2 tasks. If one task can be formed in A ways, another task can be formed, this should have an S, A ways, another task can be formed in B ways, and another task can be formed in C ways, and so on, then all the tasks can be formed in A times B times C. The key thing here is I can only be picking one of those tasks though, right? Like I said, if I could pick 2 colors, I wouldn't be able to use the fundamental counting principle, which is the blanks. Because each blank represents choosing one of each item. So if I chose one model and one color and one edition, I could do this. But if it was like one model and 2, I'd be like, nope, can't do this. Because if I have to do 2, I can't use the blank. The blank means I'm picking one of it. Okay? Also, the other key thing for you to know is if it says and, if we use the word and, which we do, we wanted an addition and a model and a color, correct? We didn't want just an addition and or a color. So I could have an addition, I could have a car, or I could just be holding a color. Can I drive a color? You can't drive a color. It's the thing. You can't, like, I'm driving blue. What blue what? I'm driving blue. There it is. Cool, blue. I hope it's nice. All right. So we need to use the word and. We need the model and the color and the addition. And when we use the word and, we multiply. Very important. Whenever you use the word and, you multiply. Your little thought bubble. That's what you're thinking. And I multiply. What does this say? Your turn. What does that mean? It's your turn. Go. Yeah, I do it for you. You're such a silly. Let's remember what we just did. Oh. So, we listed model at the top, and then we listed the 3 models down, correct? So this one, we're going to put part 1 or head at the top. That's fine. Part 1 or head. That's fine. But we don't list what those options are beside it. Where do those options go? Below it. If you're going part 1 arrows, part 2 arrows, part 3 arrows, are they ever intermingling together? The answer is no, they're not. So we do part 1, and then we list it. It is red, blue. Look at yours. Do you have anything coming off of red or blue? Do you have anything coming off of red or blue? If you do not have anything coming off of red or blue, you're not drawing a tree diagram. You're drawing 3 shrubs. Just on your page, never intermingling. You just got 3 random shrubs floating on your page. So what I'm seeing a lot is this. Head, red and blue. And then I'm seeing another random shrub. The random shrub next is body. This is not right. Here's another random shrub, orange, white, black. Are these shrubs ever intermingling? To find out, like, so what we need to know that there's a red part 1 to an orange, white. So like these have to be off of this, and these have to be off of this, correct? Like there has to be arms coming off of these to say that it's red with this body and blue with this body, correct? So if you just have 3 shrubs just sitting randomly on your page, are they ever intermingling? No. Going back here, do I have just like model and then Bronco Explorer Expedition in one shrub and then color gray, brown, white, black in another shrub? Is that what I did? That's what you guys did on your paper. You put head and then the 3 colors. You just did one like shrub to show all the options for the head, and then you did another shrub to show the options of the body, but you never intermingled them, ever. So you have to go red, blue is part 1. Yeah. Then part 2 goes up here, and off of these, I'm going to have arms. Off of each of the part 1 options. Off of each of the part 1 options, I have orange, white, or black. Now, watch this. I'm going to have orange, white, black. Orange, white, black. Orange, white, black. Now, the way I have it written, I can list outcomes. Red part 1, orange middle. Red part 1, white middle. A red part 1 with a black middle. A blue part 1 with an orange middle. A blue with a white. A blue with a black. Let's go back to the way you guys had it. Oh, you guys didn't go down at least, so you went this way. What was the body? What were the three colors again? Orange, white, black? This is what you guys had written. So I have a head that could be blue or black. I have a body that could be orange, white, or black. Was it orange, white, or black too? Blue and black, was that the options? I don't think so. What was this? Red or blue? Okay, I'm like, it wouldn't be black. When you guys do this, look at me. When you do this, you just summarize what they wrote above in the paragraph. You just drew it in a different way. You said the head can be red or blue, the body can be orange, white, or black. That's what you just told them. Did you tell them what the toys could look like though? That it could have a red head with an orange, white, or black body, and a blue head with an orange, white, or black body? Did you display that at all? Or did you just list the options again for them to see? You just listed the options. So in a tree diagram, the tree diagram shows the outcomes. Red with orange, white, black. Blue with orange, white, black. Does that make more sense? Is it starting to click? Because you guys just listed options for me. Then part 3 can be purple or pink. If you're listing every outcome once, that's a problem, because look at how many times I'm writing purple and pink. A lot. So for every color of head, I have to write orange and white and black. So if I have 2, I'm going to have to write these twice. If I have 6 outcomes here, I'm going to have to write these 6 times. Now I have red, orange, purple, red, orange, pink, red, white, purple, red, white, pink, red, black, purple, red, black, pink, blue, orange, purple, blue, orange, pink, blue, white, purple, blue, white, pink, blue, black, purple, blue, black, pink. Do you see all the different outcomes? Okay? You need to be able to do tree diagrams in your course, because when we go to probability, which is the last unit, and I ask you how many of the robots have pink part 3, you have to find out how many there are, and then you'd have to count up the ones with the pink part 3 and do the probability that over that. That's why the tree diagram for you guys is important. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes, correct? Because it shows you the 12 outcomes. What you guys had was 3 Todds. That's how the heck would you come up with 12 outcomes out of that? You just listed what the outcomes were. Now the fundamental counting principle, I say I'm going to take one piece of part 1, and then I list the number above. How many options do I have? 2, so that goes above. Then I'm going to go 1 of part 2, because that blank means I'm choosing 1. 1 of part 2, how many options do I have? 3, so that's going to go above. Then I'm choosing 1 of part 3. How many options do I have? 2. Now do I need part 1 and part 2 and part 3 to make the toy? Yes. So because it's an and, I'm going to multiply it. 2 times 3 times 2 is 12. Same answer. Because I know that this one goes poorly, guess what I do? I give another one. We're going to hope that this one, it clicks in. Some often takes to the third one. Okay? So you guys try that one out, number 2. So for this one, we have jersey, red or black. And this is the key thing. So read, the team plays in a different uniform each week. It's a repeat of previous uniform. A uniform consists of a jersey, pair of pants, and socks. Like if you doubled up on your socks, we wouldn't be able to do fundamental counting principle. So we're just picking one of each item, right? One of this, because that's what the blank means. I choose one. So let's hope. I didn't even go around. I'm just hopeful that you had it right. So jersey, red, black. Then we have pants. So off the red jersey, we could have white, red, or black pants. White, red, or black. And then they only have one type of socks. It's red. So how many outcomes is that? 6, right? Red, white, red, 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 black, white, red, black, red, black, black, red. So using the fundamental counting principle, we say I'm choosing one jersey from 2 options, because I listed 2 above, correct? Then one pair of pants from 3. And then one type of socks from 1. And 2 times 3 times 1 is 6. Same number. Now, this is why we have to worry about it. So, what is the probability of wearing a color rush outfit? Color rush outfits happen in the NFL. They're just the same color. Just all blue, all red. Okay? So how many, well, the only color rush we can make is red because the socks are red, right? So how many outcomes do we have total? 6. That goes on the bottom. How many all reds? 1. It's 1 out of 6. All right. Flip. I want you guys to try this one out. Jeremy wants to go shopping for pants to make sure he's enough different outfits. An outfit must have a shirt, a pair of pants, and a pair of socks. That's why we're multiplying. Do not repeat the same outfit for 48 days. In his closet, he has 8 different shirts, 2 different socks. How many pants does he need? Try this one. So Jeremy wants to go shopping, so he has a shirt. How many shirts? There's 8. And pants is what we're finding. We don't know what they are. We could make that be X, couldn't we, when we don't know what something is? And a pair of socks. From 2, and it equals 48 days. Because who doesn't do this? I'm going to look at my wardrobe. What could it be to make sense? So, we could guess and check to figure it out. Or we could go 8 times 2 is 16x equals 48. What would this x have to be? 3. We could say, oh, it has to be 3. Or you could do math, actual math, and say it's